Hello, welcome to Math Easy. Friends, today we'll discuss about two sums from Heights and Distances, the reference book written by Sinha and Sinha. So here, first sum, it is based on angle of depressions, and the second sum, it is based on angle of elevations. So we'll discuss about two sums. Sums are very easy. We have to understand the diagram first. So number one sum is the angular depressions of the top and the foot of a chimney as seen from the top of a second chimney, which is 150 meters high and standing on the same level as the first, are theta and phi respectively. Find the distance between their tops when tan theta is equal to 4/3 and tan phi is equal to 5/2. Now we will understand the sum from the diagram. Two chimneys are there. One is in the diagram OQ. As a measurement we have to consider these are not the correct measurement. So OQ is the first measurement. OQ is the first chimney and AB is the second chimney. B is the top of the second chimney. Q is the top of the first chimney. Both are on the same horizontal level. So this is the foot of first chimney. This is O is the foot of first chimney and A is the foot of second chimney. The second chimney is 150 meter high. AB is 150 meter. And here is given that from B, friends, here B is observer. We have to think B is observer. From B, Q, the top of the first chimney, is observed. So BQ is the line of observation. And from B, the foot of the first chimney is observed. So BO is the line of observation here. According to question, the angle of depression in the first case is theta and the second case is phi. Now, for that, friends, we know that angular depression or angle of elevation is formed between horizontal line and line of observation. So here line of observation we have got, so we have to draw one horizontal line. So BD is drawn parallel to the horizontal line. So BD is the horizontal line. Now between BD and BQ, this is line of observation, this angle will be theta, angle of depression for that top of the first chimney, and this is horizontal line and this is line of observation for the foot of the first chimney. So this angle will be between horizontal line and line of observation, this angle will be phi. Okay, so now we'll do some construction work first. What is that? We'll draw QP parallel to the horizontal line OA, and P meets AB, the second chimney, at point P. And we'll give name this OA as Y. We'll join the foot of the two chimneys. This is the horizontal line. So here the name is given as Y. So this measurement also will be Y. PQ also will be Y. And we have taken BP as X. We don't know this length. So BP we have taken as X. Now friends, we have to find out the distance between the top of two chimneys. So we have to find out BQ. BQ is equal to what? That we have to find out. Now here, if we see, friends, BD and QP, these two are parallel lines. BD and QP, they are parallel to each other, and BQ is transversal. BQ is transversal. So angle DBQ, this theta angle will be equal to angle BQP. So this angle also will be theta. Same way, BD and OA are parallel and BO is the transversal. So in that case, DBO, this phi angle will be equal to angle BOA. This also will be phi. Now, if other way we will think, we know that angle of elevation and angle of depression is equal for a particular case, is always equal for a particular case. If we think that way, friends, Then here observer B and O is object and Q is also object. There are two objects, B is observer. So here this angle, in the first case, this angle is angle of depression, and if we think this angle is angle of elevation, if we think Q as observer and this as object, so this is angle of elevation. So the angle of depression, angle of elevation will be equal. In this case also, angle of depression and angle of elevation will be equal. So we are getting this angle, angle BQP as theta and angle BOA as phi. So now we have to find out BQ. So friends, tan theta is equal to 4 by 3 given, tan phi is equal to 5 by 2 given. So we will take as two right angle triangle. If we take right angle triangle, one is angle triangle BQP. BQP will consider, and we'll consider right angle triangle BOA. So from these two triangles, you see BQP, this is 90 degree, we know, because the chimneys are straight and we have drawn the horizontal line. So this angle will be 90 degree, this is also 90 degree. So both are right angle triangle. So here BP by QP means tan theta is equal to perpendicular by base. So tan theta, we will get x by y is equal to tan theta, and here we will get 150 by y is equal to tan phi. Now friends, tan theta is equal to 4 by 3 given, tan phi is equal to 5 by 2 given. So we will get x by y is equal to 4 by 3, and we will get 150 by y is equal to 5 by 2. So from these two, friends, from these two equations, we will get x and y. We will solve and we will get x and y. After getting x and y, we will again consider the right angle triangle BQP. Here you see in this figure, then we will come to know as x and y. We will get the value of x and y, and then we will get that BQ square is equal to x square plus y square. In right angle triangle, hypotenuse square is equal to perpendicular square plus base square. So from here, after getting x and y, we'll get the value of BQ. First we'll get BQ square and we'll find out square root, we'll get the value of BQ. So you solve, you'll get the result. Now next sum, here you see, the sum is two stations due south of a tower which leans towards north are at distances A and B from its foot if alpha and beta are the elevations of the top of the tower from these stations. Prove that its inclination theta to the horizontal is given by cot theta is equal to B cot alpha minus A cot beta by B minus A. They are equal. So we'll understand the diagram. Here it is given that two stations due south of a tower. So we know that cardinal compass point is will be at 180 degrees. So here we have taken the horizontal line. In the here north and south directions are opposite sides, and OP we have taken as a tower. According to question, it is theta is the angle which leans towards north. So towards north, OP tower it leans and the angle is theta. So here OP tower we have taken, this angle is theta, and A and B are two stations. So one station at A, another station at B. And in this case, angle of elevations are alpha and beta. For A, alpha, and for beta, B, beta. Now friends, in this case, O is the object. Top of the tower, O is the object, and here two observers are A and B. Just opposite to this sum here, observer is 1, objects are 2. Here, observers are 2, object is 1. So this is object and from A point and B point the object is observed. According to question, the distance from the foot of the first tower of first station is A and distance of second station from the foot of the tower is B. So here we have made one construction, that is, we'll draw perpendicular from O on the horizontal line OQ. OQ perpendicular is drawn. This is the height of the tower. So we give name as H, and the distance of the base of the perpendicular and the tower base is Y. We have taken it as Y. Okay. Now here we'll see this is object. So A point is the observer. So here this is line of observation. OA is line of observation, and this is horizontal line. This line is horizontal line. So alpha angle will be OAQ. OAQ will be angle of elevation in this case. So this angle will be alpha. Second line of observation, here B is observer and O is object. So this is line of observation, OB is line of observation, and BQ is horizontal line. So angle OBQ will be beta. According to question, this will be beta. So now the sum will be very easy, friend. We are getting three right angle triangles. One is angle OPQ. Triangle OPQ. OPQ. This right angle triangle we are getting. So tan theta is equal to H by Y. Here cot theta is given. So first we'll find out tan theta, then we'll reverse it, we'll get cot theta. We have to prove this one. So here tan theta is equal to H by Y. We are getting three right angle triangle. Another we are getting OAQ. This right angle triangle OAQ. Here OQ by AQ will be tan alpha. So we can write H by A plus Y, because AP is equal to A and we have taken PQ is equal to Y. So right angle triangle, if we think OAQ, what we are getting here? H by A plus Y tan alpha is equal to H by A plus Y. And another right angle triangle we are getting OBQ. OBQ. From there what we are getting? Tan beta is equal to H by B plus Y. Tan beta is equal to H by B plus Y. Now we will solve, friends. We have got tan theta. So we will reverse it. We will get cot theta as Y by H. We will reverse it. And here tan alpha, we need cot alpha. So we will reverse it. We will get cot alpha. Then B cot alpha will multiply with cot alpha. B will multiply both the side. B will be multiplied. Then we will find out A cot beta. Tan beta we have got, we will get cot beta, then we will multiply with that A cot beta, then B cot alpha minus A cot beta we will get from these two equations, and we will divide by B minus A, we will get that as Y by H, means cot theta we will get. So that way you solve, you will get the result. Thank you, friends.